তো এই সাবজেক্টটায় তো ম্যাথমেটিক্যাল জিনিস কিছু নেই, তোমাদের থিওরি বেশি আছে। তো আমরা মানে চেষ্টা করব যে প্রিভিয়াস ইয়ারের কোশ্চেন গুলো একটু দেখার, তাহলে মানে তোমাদের পরীক্ষার সময় সুবিধা হবে। তো আজকে ফার্স্টেই যেটা শুরু করব সেটা হচ্ছে লেভেল কন্ট্রোল। সো লেভেলটা কি, মানে ফ্লুইডের উচ্চতা, মানে ফ্লুইড কতটা আছে, ধরো কোনো একটা পার্টিকুলার ট্যাঙ্কে বা কোনো জলাধারে কতটা আছে, সেটা হচ্ছে মানে তার যে লেভেল, মানে সেটা কতটা, সেটা হচ্ছে সেটা দিয়ে সেটা ইন্ডিকেটর, সেটা ইন্ডিকেট করে। এখন সেই লেভেল কি করে কন্ট্রোল করবে? আর dozen ways to measure fluid level. The demands of sophisticated automated processing systems, the need for ever tighter process control with an increasingly stringent regulatory environment drive process engineers to seek more precise and reliable level measurement systems. Improved level measurement accuracy makes it possible to reduce chemical process variability, resulting in higher product quality, reduced cost, and less waste regulations, especially those governing electronic records, set stringent requirements for accuracy, reliability, and electronic reporting. The newer level measurement technologies help meet these requirements. Level measurement technology in transition. The simplest and oldest industrial level measurement device, of course, is the slide glass. A manual approach to measurement, slide glass, have always had a number of limitations. The material used for its transparency can suffer catastrophic failure, with ensuing environmental insult, hazardous condition for personnel, hazardous condition for personnel and or fire and explosion. So seals are prone to leak and build up. If present, obscures the visible level. It can be stated without reservation that conventional slide glasses are the weakest link of installation. They are therefore being rapidly replaced by more advanced technologies. Other level detection devices include those based on specific gravity and a physical property most commonly used to sense the level surface. A simple float having a specific gravity between those of the process fluid and the headspace vapor will float at the surface, accurately following its rises and falls. Hydrostatic head measurement have also been widely used to inner level. When more complex physical principles are involved, emerging technologies often use computers to perform the calculations. This requires sending data in a machine-readable format from the sensor to the control or monitoring systems. Useful transducer output signal formats for computer automation are current loops, loops, analog voltages, and digital signals. Analog voltages are simple to set up and deal with, but have serious noise and interference issues. The simplest and oldest industrial signal communication is 4 to 20 milliampere current loops, where the loop current varies with level measurement, are the most common output mechanism today. Current loops can carry signals over longer distances with less degradation. Digital signals coded in any of a number of protocols. Example given: Foundation, Fieldbus, HART, Honeywell DE, Profibus, and RS-232. So, are the most common robust but older technologies such as RS-232 can handle only limited disturbances. New wireless capabilities can be found in the latest transmitted signals, allowing them to be sent over tremendous distances with virtually no degradation. As for the more advanced measurement technologies, like ultrasonic radar and laser, and the most sophisticated digital encoding formats require digital computer intelligence to format the codes. Combining this requirement with the need of advanced communication capabilities and digital calibration schemes explains the trend towards embedding microprocessor-based computers in virtually at level measurement products. See figure 1. So establish level sensing technologies. So throughout these, we assume the density of the vapor in the headspace, typically air, to be negligible compared with that of process fluid. We'll assume that also there is only one uniform process fluid in the tank. Some of these technologies can be used for multi-level applications, but two or more immiscible fluids share a vessel. So number one, glass level gauge. Available in a variety of design, most armored and unprotected glass gauges have been used for over 200 years as a simple method to measure the liquid level. The benefit of design is the ability to see the true level to the clear glass. তুমি গ্লাসের মধ্যে দিয়ে তুমি এখানে ক্লিয়ার দেখতে পাবে, এর মধ্যে কমপ্লেক্স কিছু নেই। The downside is the possibility of glass breakage resulting spills of safety to the personnel. So গ্লাসটা যদি কখনো ব্রেক করে যায় তখন কিন্তু সেই লিকুইড লেভেল কন্টামিনেটেড হতে পারে এবং যে পার্সন যে দেখবে তারও একটা সেফটি কিন্তু এরিয়া অফ মেজার কনসার্ন। নেক্সট হচ্ছে ফ্লোটস। Floats work on the simple principle of placing a buoyant object, মানে প্লবমান object একটা with a specific gravity intermediate between those of the process fluid and head vapor into the tank, then attaching a mechanical device to read out its position. The float sinks to the bottom of the head vapor and the floats on the top of the process fluid. While the float itself a basic solution to the problem of locating a liquid surface, reading a float's position, that is making an actual level measurement, is still problematic. Early float systems use mechanical components such as cables, tapes, pulleys, and gears to communicate level, and magnet equipped floats are popular today. Early float level transmitters provided a simulated analog or discrete level measurement using a network of resistors and multiple reed switches, meaning that the transmitter's output changes in discrete steps. Unlike continuous level measuring device, they cannot discriminate level values between the steps. So তোমাদের পরীক্ষায় কিন্তু মানে প্রশ্ন দেয় যে লেভেল কন্ট্রোল এটা শর্ট নোটস হিসাবে আসতে পারে, আর ডিফাইন টাইপস অফ লেভেল কন্ট্রোল বর্ণনা করো, এরকম আসতে পারে আর কি। নেক্সট হচ্ছে হাইড্রোস্ট্যাটিক ডিভাইসেস। So hydrostatic deviceগুলোর মধ্যে কি কি? Displacer, bubblers, and differential pressure transmitters are all hydrostatic measurement device. Any change in temperature will therefore cause a shift to the liquid specific gravity, as will changes in pressure that affects the specific gravity of the vapor over the liquid. both result in reduced measurement accuracy and displacer যেটা সেটা হচ্ছে works on Archimedes principle. So এখানে দেখানো হয়েছে so a column of solid material the displacer is suspended in the vessel. The displacer density is always greater than that of the process fluid. It will sink in the process fluid and it must extend from the lowest level required to the least to the highest level to be measured. As the process fluid level rises, the column displaces a volume of fluid equal to the column's cross-sectional area multiplied by the process fluid level in the displacer. A buoyant force equal to the displaced volume multiplied by the process fluid density pushes upward on the displacer, reducing the force needed to support it against the pull of gravity. The transducer, which is linked to the transmitter, monitor and relates this change in force to level. A bubbler type level sensor is shown in figure 3 in data. এখানে কি হচ্ছে that this technology is used in vessels that operate under atmospheric pressure. A deep tube having its open and near the vessel carries a purge gas, typically air, although an inert gas such as dry nitrogen may be used. When there is danger of contamination or an oxidation reaction with the process fluid into the tank, a gas flows down to the deep's tube outlet. The pressure in the tube rises until it overcomes the hydrostatic pressure produced by the liquid level at the outlet. The pressure equals the process fluid density multiplied by the depth from the end of the deep tube to the surface and is monitored by a pressure transducer connected to the tube. A differential pressure level is shown in figure 4. The essential measurement is the difference between total pressure at a tank or hydrostatic head pressure to the fluid plus static pressure in the vessel and the static or head pressure in the vessel. As with the bubble, the hydrostatic pressure difference equals the process fluid density multiplied by the height of the vessel. Uses atmospheric pressure as reference. So, তোমাদের প্রশ্নটা একটু প্রেসার top headspace pressure equal to the atmospheric pressure. In contrast to the bubblers, DP sensor can be used in unvented pressurized vessels. All this is required to connect the reference port, the low pressure side, to a port in the vessel above maximum fill level. Liquid purges or bubbles may still be required depending on the process physical conditions and or the transmitter's location relative to the process connection. So তোমাদের